Good morning, students. My name is Teacher Monique P. De La Cruz, your facilitator for today. Before we proceed to our lesson proper, let's ask guidance from our Lord Jesus Christ by taking a moment of silence. So now, let's start our class with an activity entitled Letter Struggle. In this activity, jumbled letters are flashed in a presentation and you have to arrange it to come up with a word that corresponds to a given definition. You have 5 seconds to answer it. Ready? First jumbled letter. The hint is, it is a form of energy that makes it possible to see things. The answer is light. Second jumbled letter. The hint is, it is the number of waves that pass a fixed point in a unit of time. The answer is frequency. Third jumbled letter. It is the ability to do work, which is the ability to exert force causing a displacement of an object. Yes, it is energy. Fourth jumbled letter. It is a tiny particle that comprises a waves of electromagnetic radiation. That's right, it is a photon. Let's read the objectives. At the end of 60 minutes period, at least 75% of third-year students will be able to, first, define what photon is, second, identify the properties of photon, and lastly, solve the energy of photons using the formula. Energy of photon is equal to Planck's constant times frequency, or energy of photon is equal to Planck's constant times the speed of light divided by lambda or wavelength. Light is a form of energy made of photons. A photon is the smallest unit of visible light. Photons can be both waves and particles. For you to deeply understand our lesson for today, let's watch this video.
Yeah. The photon theory of light says that light energy comes in tiny packets called photons. So a beam of light is a stream of energy balls traveling at the speed of light.
Nonsense! I don't see balls coming out of lamps.
Just like you don't see H2O molecules coming out of taps, right? According to the photon theory, the amount of energy a photon carries is directly proportional to the frequency of the light. E is equals to hf. H is Planck's constant, which turns out to be a very small number. So photons come in really tiny packets. The photon theory directly contradicts the wave theory of light, which says that light is an electromagnetic wave. According to wave theory, light energy arrives continuously regardless of frequency of light. According to the photon theory, light energy arrives in discrete lumps, and the frequency of light determines how lumpy they are. According to wave theory, the difference between dim light and bright light is in the amplitude of the oscillation of the electromagnetic field. According to photon theory, the difference is in the rate of arrival of photons.
So which theory is right? Waves or balls?
In the 1800s, thanks to Young's double-slit experiment, everybody thought that light is a wave. 100 years later, the photoelectric effect and Einstein came along, and everybody changed their mind. Light is a stream of photons.
Good! I prefer balls. Einstein likes balls too.
watching the video, what are your insights about photons? Very good. Light travels through space as an electromagnetic wave carrying energy. The energy per unit area and the unit time is defined as intensity, which is directly proportional to the square of amplitude of the electric field of light wave. This energy is not continuous but arrives in discrete units called photons. As atom is the fundamental unit of matter, photon is the basic unit of light. So what are the properties of photons? Very good. Photons are electrically neutral. Its velocity is equal to the speed of light and are massless. It can be created and destroyed while conserving energy and momentum. So how to calculate the energy of photons? Correct. Photons can be calculated in two ways. First, if the photon's frequency is known, we can use the formula E is equal to h times f. Max Planck proposed this equation, which is why it is known as Planck's equation. Second, if the photon's wavelength is known, the photon's energy can be calculated using the formula E is equal to h times c divided by lambda. The constant value here is the Planck's constant is equal to 6.63 times 10 raised to negative 34 joules per second. The second one is the speed of light, which is equal to 3.0 times 10 raised to 8 meter per second. To deeply understand our lesson, let's have another activity. Answer the following questions and try to solve the problem by using the given formula. Write your answer in a one whole sheet of paper and you have 10 minutes to accomplish it. Timer starts now. Time's up. How did you find the activity? It's good to hear that you enjoy it. Now, let's further discuss the activity. As I said a while ago, photons are fundamental particle of light. It is basically the most visible portion of electromagnetic spectrum. Albert Einstein proved that light is a flow of photons. The energy of these photons is the height of their oscillation frequency and the intensity of light. He also explained how a stream of a photon can act both as a wave and particle. Again, photons have specific properties. Photons have no electric charge, a spin of 1 with 2 possible orientation, a zero rest mass, which make things about photons possible. Their speed almost 3 million meters per second, their energy being proportional to their momentum, and inability to experience time and space. Can we relate photons with time? The answer is no. Time does not exist from the viewpoint of a photon. There is zero time in between when it is released and when it is absorbed again. It can take photons hundreds of thousands of years to travel from the sun's core to its surface and launch into space. In empty space, photon travels at the speed of light. So now, let's compute the equation I presented a while ago. Photons can be calculated in two ways. As I stated, if photon's frequency is known, we can use the formula energy of photon is equal to Planck's constant times frequency. On the other hand, if the photon's wavelength is known, the photon's energy can be calculated using the formula energy of photon is equal to Planck's constant times the speed of light divided by wavelength or lambda. Planck's constant is equal to 6.63 times 10 raised to negative 34 joules per second. And F is the frequency, tells you what type of light it is, and in visible range, it tells you color. So, the energy of a photon is a constant times its color. In the equation, the photon's frequency is given, which is 2 times 10 raised to 6 Hertz. Therefore, it will use the formula E is equal to H times F, or energy of photon is equal to Planck's constant times frequency. The given R, Planck's constant, is equal to 6.63 times 10 raised to negative 34 joules per second, and frequency of 2 times 10 raised to 6 Hertz. We will replace Hertz to 1 over seconds to cancel seconds. It's just the same. Going back, to compute the energy of photon, Planck's constant, which is equivalent to 6.63 times 10 raised to negative 34 joules per second times 2 times 10 raised to 6, 1 over second. So cancel the second, so the remaining unit is joules. The answer is 1.33 times 10 raised to negative 27 joules. When the given is gigahertz, it must be converted into hertz. So 1 gigahertz is billion hertz. It's 10 to the 9th power. Additionally, there's another constant value, which is the speed of light, where c is equal to 3.0 times 10 raised to 8 meter per second. Do you now understand the process on how to compute the energy of photon? That's great! So to test your understanding for our lesson for today, let's have another exercise. Compute it in a one-whole sheet of paper. First question, calculate the energy of photon with frequency of 275 gigahertz. Second, what is the energy of photon with a wavelength of 500 nanometer? Also, briefly explain this question in 3 to 5 sentences. What are your key takeaways about our lesson we tackled today? For our assignment, in a one-whole yellow paper, research and make a reflection about photoelectric effect. Thank you so much for listening, and God bless.